Welcome to AEC example number 5, and it is asking to solve for AH and BH. And these are reactions. This is the way I'm looking at them. And a reaction is typically you're going to have your structure, as I would call it, right here. And then this is a wall or something. So when one structure contacts with another structure, you have reactant or reactions. So let's say if you have a beam doing bridge design, or it doesn't have to be bridge design, and you'll have an abutment and abutment. You have a bearing pad right here and a bearing pad right here. This is a concrete beam, and you're looking at the beam. This will be a reaction right here. This will be a reaction right here. And that's what we're talking about, reactions. Just a quick, simple way to describe that. And then looking at this as well, we know that these are pins. A is a pin connection, and B is a pin connection because they only resist vertical and horizontal directions, vertical, horizontal. So we know there's pins. If they also resisted moments, then it would be a fixed connection. But it doesn't. It allows it to freely move in the moment direction. Obviously it's not going to because you have two pins, but anyways. Alright, so this is a free body diagram now. You'll only have reactions and your loads. Your reactions are BH, BY, AH, AV, and our loads are 200 and 400 pounds. Now, when you have a free body diagram, as soon as you do that, you need to solve for your reactions or your unknowns. And to do that, you use these three equations, and this is huge for free body diagrams. This is how you solve free body diagrams. You have three equations. You have the sum of the forces in the x direction equals 0, sum of the forces in the y direction equals 0, or the sum of the moments about any point equals 0. So you have to choose a point. You can either choose B, choose A. You could choose some point out here. And the reason to do that is, for instance, if you're wanting to solve for, you know, let's say you want to solve for this, you could make an arbitrary point out here, and you could do the sum of the moments out there if it behooves you. And you'll see that later when you have a truss where you're looking at it like this, and you decide to you cut the truss right here, and you're going to you know, sum of the moments about this point over here that your truss isn't actually touching, so that you can solve for this. So you're going to have, let's say, tension or compression, and you want to get rid of these two unknowns. So you sum it about this point because you want to find this force. So in other words, your point doesn't have to be on the structure. It can be anywhere, but typically it will help you out if it's on the structure, and you'll see that right here. Alright, we're going to go ahead and start solving. The first thing you want to do is, not 90% of the time, but a few percent most of the time, is you want to take the sum of the forces in your moment, in sum of the moments equals 0. Because you're not going to have, the forces aren't going to line up to where you only have one force. Like right now we have two forces in the y direction, so we can't isolate one of them. And you have two forces in the x direction, so you can't isolate one of them. You want to isolate one of these unknowns so that you can solve for it. And that's the easiest way. And just because you can't isolate one doesn't mean you can't solve for it. You just have to solve for one and then substitute with a variable in there, and I hope that makes sense, but it might not, and you will see it later on, I'm sure. It's just more complicated problems. So first thing we're going to do, you can either sum the moments about A or B, and because what that will do is that will isolate either BH or AH. Because if you sum the moments about A, AV times, well, what's the distance perpendicular? It's not any perpendicular, so it's 0. So AV times 0 is 0. AH times 0 is 0. And then BY also is 0. Or and then BH, it's perpendicular, what, 5 foot? 5 foot perpendicular. So you're going to say BH times 5 foot, and that should be a negative BH or whatever, if that's what you're, I'll show you that in a second. And then you also take 200 times 10 and 400 times 10, and then you solve for BH. Or you can do about some of the moments about B, and let's see what he did, and I'm going to do the opposite. Sum your force, and he doesn't say what he does. Lines of action. He says take moments about A. All right, well, we're going to take moments about B. If you want to see how he does it about A, that's great. I'm going to go ahead and do the sum of moments about point B equals to 0. And we're going to go ahead, if you're summing the moments about B, your AV is going to equal 0, BY is going to be equal, or AV times 0 is 0, BY times 0 is 0, and BH times 0 is 0. So we're just not even going to write those. Now you have AH is your one variable that you're going to solve for, and it is, okay, also when you're doing this, you want to put what your positive moment is over here. So every moment going that way is going to be positive. I'm at B. This moment, AH is going to induce a moment going that way. So that's negative. So I want to say negative 5 foot. So that's AH times the distance it is parallel from the point. It's 5 foot. Sorry, got to get rid of that. Negative 5 foot. Now let's do plus. Now we know those three are 0, or will induce no moment. Now we have to look at these. These are 200 times, well, it's actually concurrent with B, and these are all concurrent as well. So it's not going to induce any moment. So 200 pounds times 0 foot equals 0, and then 400 pounds is 10 foot away. It's parallel 10 foot. So we want to do, and that's going to be in, it's going to go, moment's going to go that way, and that's our positive direction. So it's going to be 400 pounds times 10 foot. And now we solve. We've got all of our stuff up here we want to solve, and we want to solve for AH, and this is just a matter of algebra. We'll start with this. You have 400, I think that's 4,000 foot pounds, and that's a moment unit, and that will give you, well, let's go ahead and AH, negative 5 foot plus 4,000 foot pounds. And then to get rid of this, you subtract 4,000 foot pounds to both sides, and this is 0 initially, so you're adding a negative 4,000 pounds. So this is negative 4,000 pounds. That's foot pounds. I'm an idiot. Pounds foot. Some people do it like that. Equals AH negative 5 foot. Now to get rid of negative 5, you divide by negative 5 foot to both sides. And then I'm going to bring it over here. So AH. And if you don't, you don't feel comfortable with this, go over algebra stuff, or just continue doing these and get a piece of paper out and do it ahead of time. Stop the video and just say, I'm going to do this myself. And if you get it wrong, who cares? Because nobody's watching. Nobody cares if you get it wrong. This is all in your head. It's what you learn is important. So negative 4,000 divided by 5 is 800. So 8H. Then let's look at the, oh, that's 800, not 8,000. Let's look at the, we have foot, and you're dividing by foot, so it's going to be pounds. And does that make sense? Yes, because our loads are in pounds. So that makes absolutely sense. Good sense. Now, once again, we're only solving for AH and BH. So now AH and BH are both horizontal X loads, let's call them. Well, now we only have one X load left. Horizontal load, let's call it, instead of X load. So we can use sum of the forces in the X direction to solve for the rest of this. So let's go ahead and do that. Because we only have one unknown force in the X direction, we can solve for it. Sum of the forces in the X direction equals 0. Equals, now BH, oh, real quick, I'm going to go over here. Since this is positive 800, that means that this arrow is going the right way. If it were negative 800, that means the arrow, we assumed if we drew it this way, the arrow would be in the wrong way. I always make the arrows go positive, and then, for instance, they did this, BH, they made it go to the left, meaning they already know what it is. So it's probably going to be positive. But I would have done that, and I would have got a negative number knowing that it actually is going that way. Hopefully that makes sense. So we go back up here, and sum of the forces in the x direction equals 0. And we know we have a negative 200. Let's go ahead and put it down here. Give me a little bit more space. Negative 200. That's kind of jacked up. And then positive 800. And then a negative BH. The BH goes that way. So negative BH. And we want to solve for BH. So this equals 600 pounds. Negative BH equals 0. We want to switch this over, so you add BH to this side, you add BH to this side, so you get BH equals 600 pounds. And let me see if that's correct. BH equals 600 pounds. And those are your answers. BH equals 600, and AH equals 800. And once again, you could go ahead, since BH is positive, we know that he got the right, but you can just go ahead and draw an arrow next to your calc to know, hey, BH goes in that direction, so you're not confused. You don't have to, but anyways, those are your answers. Hopefully that helps.